find and describe the discontinuities in g of x equals, and we have a piecewise defined function here, it equals 1 over x squared if x is not equal to 0, and 1 if x is equal to 0. Now, let's do a quick sketch of what this graph looks like. Now, I don't know if you have seen the graph of g of x equals 1 over x squared before. It does have a lot of similarities to 1 over x, but the shape is a little bit different because it's x squared and not x. And also, this function is never negative because any number squared is positive or 0, and 1 divided by a positive number is always positive. So effectively what we get is something that is kind of shaped like 1 over x. It's not exactly shaped the same way. It is a little bit different. In fact, it's meant to be perfectly symmetric. It is an even function, but I am not a robot. I'm a human being, so it's not very perfect there, but we shall survive. But the thing is, it doesn't dip below the x-axis because anything squared is positive. So it ends up looking something like this. Of course, it has a horizontal asymptote that's the x-axis, because as x gets larger, we know that the limit of this as x approaches infinity or negative infinity is 0. We've done enough limits in infinity to see that. And then also, of course, it's undefined. This portion at 0, we have vertical asymptotes there, because as x gets smaller and smaller and smaller, this fraction gets larger and larger and larger. So the graph looks something like this. If you don't know what this graph looks like and you didn't have me describing it to you, remember, you can always make a table of values, connect the dots, see what it looks like that way. So you have other tools in your tool belt if you've never seen this before and you don't already know what it looks like. And then at x equals 0, we're told that the function value is 1. So we can just make that 1. Remember, this is just a very rough sketch here. So 1, 2, etc. And so we have an idea of what this graph looks like. Not a perfect graph, but whatever. Good enough for our purposes. And we want to know where the discontinuities are. And it is definitely continuous for the positive and negative x values. It's a beautiful smooth curve. Nothing weird going on there. But we do have a discontinuity at 0. And it is what type of discontinuity? It is an infinite discontinuity. And this is at x equals 0. Anytime we have vertical asymptotes, whether it's two-sided or just one-sided, whether it's going up towards positive infinity or down towards negative infinity, always those are classified as infinite discontinuities. And that is the only one that we have in this problem. Everywhere else it's continuous. It's just that one x value.